Our last lesson on thermal energy for ICP, and we want to talk a little bit about practical applications. We've talked about the laws of thermodynamics that tell us what we can and can't do, and we've talked about how energy is transferred. So let's talk about this in real life. So first of all, you see on the right side over there the steam engine. That's an example of an external combustion engine. In a steam engine, coal is put into a big open furnace, more or less, and the coal is burned to generate steam, and that steam is actually what runs the locomotive. So I burn the coal outside the engine, and the results of that burning the coal, which is the steam, is what really runs the engine. And then internal combustion engines, like the engine in your car, is an engine, a heat engine like we talked about before, that burns fuel inside the engine. So you've got a gas tank, the gas gets injected inside the engine, there's a spark that ignites it, that starts a fire in there, and that causes parts of your engine to move, which eventually makes your car go. So the fuel gets burned inside the engine in an internal combustion engine. The other major practical application of thermal energy is your heating and cooling system. So you have most likely a central heating system in your house or apartment or whatever, where there's one central place to generate the heat, and then that heat is sent out to the rest of the building. There are several different ways to do that. You can have electric heaters, which usually run along the base of the walls, the baseboards. Forced air is the most common kind of heating system. That's a furnace in the middle of the house that a big fan runs. You hear the fan start, and then you feel the hot air coming through the pipes in your house. Hot water and steam are used in kind of downtown city situations and older apartment buildings, where instead of pushing hot air through those pipes, it's hot water and steam that gets pushed through, and as that hot water goes through the pipes, the heat from that radiates into the room. Another thing that has become much more popular in recent years is a heat pump. And so a heat pump actually takes energy from a cool place. So a heat pump can work to take energy out of your house during the summer or put energy into your house during the winter, but it takes that energy from someplace else. So it takes the energy out of the air in the wintertime, or in the fall usually, not so much the winter, and uses that energy to pump into a warmer place. And it does that using a refrigerant. So a refrigerant is a fluid, and these in the past have been, you've heard of CFCs probably, which have damaged our ozone. But this fluid is inside a tube in a heat pump. As the heat is pulled out of the air around it, that heat goes into the fluid in that tube and absorbs that heat, and as it absorbs the heat more and more, it warms up and vaporizes, and then it cools as it goes through the tube and condenses back to the original spot. The same thing is true in your refrigerator. So on the back of your refrigerator, although the inside of the refrigerator is very cold, the back of your refrigerator will be very hot, where this absorbing of energy and carrying it away by vaporizing and condensing, that takes the energy out and carries it back outside the refrigerator.